angle, which means larger than 180 degrees. Now, what I want you to do right now is take out your calculator. I want you to find out what the angle is here. What does the angle equal here? So the ratio is 1/2. What's the angle here? 30 degrees. Okay. So if I have a ratio of 1/2, my triangle has, my angle on my triangle has an angle of 30 degrees on it. Okay? I want you to punch this into your calculator now. And tell me what the ratio is for sine of 150 degrees. 5.
1/2.
1/2. It's the same thing. Okay? So what we're learning right now, and this is very important, is that there are two possibilities for the sine of an angle to give us the same ratio. And the two angles will be supplementary to each other. Supplementary means that the two angles will add to give you 180 degrees. So let's check that. Let's go sine of sine of 50 degrees. And what's supplementary to 50? 130. 130. Calculate what the sine of 130 is.
Same thing.
Same thing. All right. Now, when I punched in the second function sine of 1/2, I only got 30 degrees. I didn't get 150 degrees. Okay? So when you use the second function sine, when you're looking for an angle based on the sine ratio, it will always give you an angle less than 90. But you need to remember that there is a possibility that there will be an angle greater than that has the same ratio, one that is supplementary to that angle. Now, where we're going with this is simply this. If I take a triangle, and this is where we're leading to, and I have to measure this angle. Let's say that this angle is 30 degrees. There's going to be, based on whatever this side is, I'm going to make this side length 10. There's going to be 3 possibilities, depending on what the length of this third side is. Okay? There's going to be 3 possibilities. The first possibility is that no triangle exists. The second possibility is that there's one triangle that exists. And the third possibility is that there's 2 triangles that exist. Okay, so we want to figure out how this all works. So the first thing I do is I want to find out the minimum value of that length that's going to create one triangle. And that one is one in which the side just hangs straight down. That's the minimum distance from there to the other side of this triangle, in which I can create a triangle. To get that forms a right angle. To get that, I take the sine of 30 degrees and I times it by 10. Well, we just figured out what the sine of 30 was. What's the sine of 30 degrees? 0.5. So I take 0.5 and I times it by 10. What do I get? 5. I get a side length of 5. If this length is given to you and it's anything less than 5, it won't hit this side. Think of it like a string that's hanging down. This is the distance of the string from here to here. That length is 5. If I cut it off at 4.5, does it reach the other side? No, it doesn't. All right? It has to be a minimum of 5, whatever units it is, whether it's centimeters or whatever. It has to be a minimum of 5. That's going to give me one triangle. Okay? But what happens if that value is greater than 5? What happens if that value given to you is, say, 8? Well, if I let it hang straight down, it would come down here somewhere, right? It would be down there. This length here would be 3. Correct?
Yeah.
So now, let's swing that string up. We're going to swing it in 2 directions. I'm going to swing it this way. So there's one triangle right there. Right? Okay? I said that length is 8. But let's swing it this way now. It's right there. I'm going to have a second triangle. That triangle will be this guy right here, in which that is also 8. Okay? So there's going to be rules to this. This is what we call the ambiguous case of triangles, in which we have to decide, is there 0 triangles, is there 1 triangle, is there 2 triangles? And then we go ahead and we solve all 3 triangles. Okay? So that's where we're leading to this. So what is the importance of knowing that there's 2 angles given to you when you find sine that are supplementary to each other? Is we can create more than 1 triangle based on the information we're given, and we have to be aware of that. Yeah.
So the height can be 8 even though the other side length is 10, or it'll have to be different side length.
I don't understand your question.
Like you said that the height can be 5 or 8.
Well, it depends what's given to you.
Okay.
They're gonna tell you. They'll give you this angle. They'll give you the measure of that side, and they're gonna tell you what the length of the other side is.
Okay.
And your job is to figure out whether there's 1 triangle, 1 triangle, or 2 triangles.
Okay.
So to do that, the first thing you do is find out what's the minimum length it has to be.
Okay.
Okay? And then once you get that height, you'll know whether or not you have 0 or 2 triangles or 1. Okay? So that's where we're going with this. The first section of this 4.1, if you look at the top in the corner there, they say that sine theta, which is what I just explained to you, is going to give you the same as whatever sine 180 degrees minus theta is. Okay, so if sine theta is 30, that should be the exact same thing as what sine of 150 is. If the sine of this angle is 70, that's going to give you the sine of 110. They're going to be the same. That's what that means, yes.
What is this theta?
Theta is just an angle. It represents any angle. Okay? So whatever I put in there, it's just an angle. We use A, B, C, but in math we use thetas, alphas, betas, okay? Greek letters that represent angles. So it represents any angle. The same doesn't work for cos. Cos is actually the negative of the supplementary angle. So what that means is this. Put into your calculator the cos of 60 degrees right now.
Second function.
Nope.
0.5.
Cos of 60 degrees is a half, isn't it?
Yep.
Okay? So if I take 180, subtract 60, what do I get? For me? 120. Now what I want you to do is put negative cos 120 into your calculator. And I should end up with the same thing. Okay? Now, it's not as important that we remember this. The sine is the one that is absolutely essential for us. The sine is the one that's essential for us. The cos and the tan, it doesn't much matter. Tan works the same way as cos. So, for those of you that take pre-calculus, we studied a lot of this, and you'll understand why all of this works out in the long run. Take the tan of 45 degrees.
One.
1. Take the negative tan of 135 degrees.
1.
1 as well. Okay, so it works the same way. But like I said, I'm not focused on these two. I am focused on that one.
You said tan is how many degrees?
45.
45.
And then negative tan
Of 135.
and second function tan should equal 1. Like the second function tan 135.
Yeah.
Should equal 1.
Negative. Second. No. Negative tan 135. Not second function. You're not finding the angles. I'm giving you the angles. You're finding the ratios. So negative tan 135. Good?
Yep.
All right, flip over to 88. I'm going to put this into practice. And again, basically the beauty of this is this first section just is a carry on of what we have just done. We are still using law of sines and cosines for this whole section. So you're still using the same stuff, same information. This is 11 centimeters. This is 9 centimeters. This is 48 degrees. It wants you to find angle C. Now, just the visual of angle C. Does it look like angle C is an acute angle or an obtuse angle?
Obtuse.
Obtuse. Why?
It's larger than 90.
It looks like it's larger than 90, doesn't it? Okay, well, let's find out what happens here. So I go sine C over 11 is equal to sine 48 over 9. C is equal to. What do you get here?
You get 65. And 269. 270.
So it's 65.270 degrees. Now is that an obtuse angle?
No.
No, it's not. But looking at our visual there, it should be. Okay, so the first thing I want you to do right now is I want you to take 180, subtract that, subtract 48. $66.73. 0.73. That's zero, right?
So it could just be the way we drew it, or?
No. Let's just keep going with this. Let's find the length of that other side.
Well, it looks like the very word.
So let's find the length of B here. So B over sine 66.730 is equal to 9 over sine 48. $11.126. Does the length of that side look larger than the length of the
No.
11? It doesn't, right? So then we have an issue here. Our issue is that when we calculated that first angle, it gave us an acute angle, but we can clearly see from our diagram that that should have been obtuse. So what do we know to do then? Well, as soon as I find my C, I'm going to take 180 degrees and I'm going to subtract 65.270. Let's find out what that's equal to. 113 point.
2700.
I got 114.73.
I thought it was just retarded.
114.730 is my guess. Is that right?
Yeah.
Okay. All right.
Oh,
What'd you put in?
66.
Okay.
Where do we get 65 from?
That was our original angle right here.
First one.
All right, so if that's the case, then it's 114.730. Does that make more sense for this diagram?
Yeah.
Yeah, it does. So none of the rest of this information, this isn't going to be right. So let's now find what this angle is up here now by taking 180, subtract 48, subtract 114.730.
So
I've got, this is 114. I got that. What'd you get?
But why 17? 27.
Oh, that's your question. What's that?
17 doesn't.
17.270 degrees.
so when we did it the first time, we found the other side of the.
No, I found that angle. The law of sines will only give you a ratio that's less than 90. But if it doesn't look like it's less than 90, then I subtract it from 180 to find out what the obtuse angle is. So that's what I did. Now I get 114.730. Anytime you use this equation and sine, it will only give you an angle less than 90. But if you need an angle that's greater than 90, all you do is take that angle and subtract it away from 180. Okay? Because they'll give you the same ratio. Take the sine of 114.730 right now. Sine 114.730.
0 less than 908.
Take the sine of 65.270.
That's the same thing.
Same thing, isn't it? So that's what I'm saying, is it's possible for you to have two angles with the same ratio as long as they're supplementary to each other. So every time you do this, you're going to look and see, is it obtuse, is it acute? If it's not acute, then we're going to change it to an obtuse angle by subtracting the angle from 180. That's all there is to it. That is the only thing that's new today to you. All of the triangles we looked at for the last week were all less than 90. Today, we're going to have one angle greater than 90. And to get there, you find it using your law of sines, exactly what you did before, and then you subtract it from 180. Okay? Let's look at the next example, too. As they've drawn it, does it look like E is greater than 90 or less than 90?
Greater.
Looks like it's greater. And when I look at the side lengths, does it look like it should be the largest angle?
Yeah.
Okay, so how do I find this angle if I've given three sides?
Law of cos.
Law of cos, that's right. So let's use the law of cosines. So I'm going to cheat a bit here and I'm just going right into it. So cos E equals
20 squared.
20 squared minus 12 squared minus 9 squared. Okay, get the angle E then, please.
144.119 or 114.
144.114 degrees. Is that an acute angle?
No.
No, it's obtuse, and that's what we were looking for, wasn't it? Okay. The law of cosines, when you take the second function of cos, it will give you an angle between 0 and 180 every time. It will give you an angle between 0 and 180. And so it will give you obtuse angles. Sine will not, but cos will. So if you're using your law of cosines for this, then that's what we got to do. Okay? That's all I asked for in that question. Okay? So the only thing new to you today is when you use the law of sines to get an obtuse angle, you take your angle that you find and you subtract from 180. Other than that, it's exactly what we did. So I guess that
When you're doing a law of sine, is it alright if like your angle is above
Yes.
one, like, punch it
I
in?
believe I did that over here. Yes. That's what
Like
you're
if
talking
your
about.
sine is like say 100, can you still,
Like
Uh,
they give you
oh
an
yeah,
angle.
if it gives you an angle larger than?
yeah, can you still work it?
Yeah. Yes, you can. That's a good question. Okay. All right.
So you'll still subtract it from 180 then?
No, it'll still give you the same ratio. It's the same. Like you just punched in 3 different values, and you got the same answer for the supplementary angles, right?
Yeah.
Yeah. Okay. Any other questions about that? Like I said, it's not new now. We're just going to carry on with what we're doing. Tomorrow, I think it is. Tomorrow, ambiguous triangles. Let me have a look here. Yeah. Tomorrow we talk about the ambiguous case of triangles, in which we have to just figure out if it's 0, 1, or 2 triangles. Other than that, it's still the same. Okay? Any questions about that? So we're going to finish off 4.1 and 4.2. Some of you have to finish your tests. So I want to see your cheat sheets on your desk right now. So if you're going to finish your test, your cheat sheet needs to be on your desk, and I want to have a look at it.
Yeah, they were talking. It's really.
Okay.
Which one? Wasn't that on the, like the pretest too? There's ones like
I want to look. If it's not on there, it was added, then I'm not going to mark it. I don't want that happening. Or else I'm not getting any more time during the test. Did you have is this yours?
Yeah.
Do you not have a piece of paper that I gave you?
No.
Okay, I'm going to give you that. No, I don't have anything next week to get some. Next test. Put it on the coin here. Okay. Do you have a cheat sheet? You need one? Hey? Okay, so she told you? Yeah, so you put whatever you want on there in one square. Okay, I'll get you. Do you have paper? Did I give you paper for it?
No.
Oh, I'll give you paper. But well, we need to, it's important that you do it. It gives you a big advantage, okay?
Yeah.
Kaden, are you done yours?
No.
You have a cheat sheet? You don't have one? Okay, you need to start one, okay?
I got a paper here.
You have a paper? Okay, make sure you have one. Okay. I have no name on this one.
Do a cheat sheet.
No, I used one yesterday though, but not yesterday.
Oh yeah, if you don't need to use John's, just put it away. You can look at it.
You guys need to communicate and do a good job with it. Because when it comes to the final exam, you're gonna need it to forget all this stuff. Yes. Oh, look, you need yours. You done? Rowan, are you done? You're done? Yes.
Yeah.
I know it looks very similar to yours, but it was on the pre-testing. The test has 1900 and I have 900, so it's really close.
Jordan.
Excuse me for the interruption. Colton Waller to room 23. Colton Waller to room 23.